Hello everybody, this is Mr. Nardelli again. Today I'm going to be talking to you about graphing linear equations. A linear equation is an equation with two variables. Both variables will be of the single power. So an equation you wouldn't have y equals 3x squared or anything like that. It will always be x and y. Sometimes they might be in the form of this, which is y equals mx plus v. That's point slope form, which we'll talk about in another video. So let's take, for example, y equals 2x plus 1. So if I'm going to graph that, I'm going to plug in three values for x. Any three values I want. I could pick 100, I could pick 8 trillion, I can pick as many decimals as I want. I'm not going to want to do that. First thing I'm going to want to do is plug in 0. The main reason is because it's easy. So if you see this equation right here, I've written in y equals 2 times 0 plus 3. So I solve 2 times 0 is 0. I'm left over with y equals 3. So I will complete my t-chart and put 3 in there. Now I'm going to plug in something else. You might as well go for 1. Pretty easy to do. So I have y equals 2 times 1 plus 3. 2 times 1 is 2. So I end up getting 2 plus 3 equals 5. So my y coordinate for my second ordered pair is 5. Now, just to make sure, I'm going to go for a third ordered pair. So I'm going to choose 2. You might choose -1 if you want. It doesn't really matter. So y equals 2 times 2 plus 3, which is 4 plus 3, which is 7. So my next ordered pair is 7. Now I'm going to go ahead and graph them. So my first ordered pair is 0, 3. So remember, that goes to the right or the left 0 times, and it goes up 3 times. So I'll put a little dot right there at 0, 3. That's going to come in handy later when we have y-intercepts. Then I have the point 1, 5, which is 1, 1, 2, 3, 4, 5. Goes right there. And then I've got the point 2, 7. Now you see I kind of go off my my graph a little bit, but I'm going to move over 2 and move up 5, 6, 7, and I'm going to have to estimate that it's about right there or so. Now, if I have done that correctly, I will now draw a line that will go through all 3 points, and it looks like it doesn't go through, but just bear with me because of that last point. Let's see, I'm going to go there, I'm going to go there, and then I'm going to put it up a little bit. I'm going to, nope, that looks good enough. So you'll see my line goes through all 3 points, and I have the linear equation for y equals 2x plus 3. Now, if we have an equation that has a fraction in it, fractions tend to be not so fun, but we can strategically create or pick our x coordinates to make whole numbers. So we're obviously going to pick 0 first, because 1/2 times 0 is 0, and then my y coordinate is -2. -2. Now I can pick 1 if I want, but if I pick a factor of 2 or a multiple of 2, I can clear that fraction. So if you notice down here, I picked 2 because 1/2 times 2 is 1. So I've got a whole number, and I get 1 minus 2 giving me -1. So I didn't have to deal with any fractions. If you do with fractions, you're still going to be okay. And I chose 4 because 1/2 times 4 is 2, and then 2 times 2 is 0. Remember, if you do fractions, you're still going to be okay. Now I'm going to graph 0, -2, which is 0, -2, right here. My next one is 2, -1. So I go 1, 2, -1, right here. It doesn't show up exactly on the line. And then I have 4, 0, which is 4, 0. Now I'll come in and draw my line. And let's see, let's try to get it straight. When you draw it, you'll get it much straighter. And I've got my linear equation for y equals 1/2 x minus 2. Now another type is when you don't have it in the y equals mx plus b form, when you might have something like this. And that should be 15, sorry about that. So in this case, you can substitute 0 for x and 0 for y. So what we're going to do is substitute 0 for x, and notice what I get down here. It totally eliminates the 3 times x, giving me 5y equals 15. Then I solve it, and I'll get y equals 3. But now what I'm going to do is plug 0 in for y, because what that's going to do over here is totally eliminate that y variable, and I get 3x equals 15, and my x is 5. Now this is one of those, oops, sorry about that, one of those cases where, that's not working too well, where you don't really need 3 ordered pairs. You can survive with just 2 of them. So notice what I've got is 0, 3, which is right here, and I've got 5, 0, which is right here, and then I'll come in and draw my line, which goes right like that, and I have my linear equation for 3y plus 5x equals 15. If you need anything, feel free to email me at nardelli.efsc@gmail.com. Thanks.